rows, you know, the 1, 2, 3. I understand that you're saying that before, if you make 4 0, why can't we make the -5 1 and make it, you know, flip side, and make the third row, make the 1 into a 1, and then the 6 into a 0.
All right, let me catch up to you. So
The top row, make the left 1 1, and the rest of them 0. On the second row, make the -5 a 1. The rest
but how do you make this a 1? How do you make this a 1?
Well, I mean, not. It's hard to.
So you could. Why couldn't I? Let me catch up to you. All right, I could work on this row before I work on that column. Sorry, before I work on this column, right? Totally. It doesn't really matter what order I do this in, as long as it ends up like this, right? Okay, that's one thing. But that would be more difficult to do for this specific one, because I can't. Why can't I use this to kill that? Could I multiply that by 5 and kill this? But if I add this row to this row, what am I going to lose? 0. Oh shit, I never want to do that. Do you see that? I don't want to lose a 0. Yeah.
So what I'm asking is that I see that we have a cat-code going on. So instead of saying, okay, I have 1, why not have them scrambled?
How do you mean scrambled? I don't...
Okay, the very top, the goal.
Yes.
We have the top left, the middle, and then the bottom right.
Sure.
Okay, why can't we have the top left, bottom right? Or
Totally, sure. Yeah, because if you do, you can just switch these. That's what I just said. So yeah, I'm going to end up with a 1 right here.
Okay.
Because I'm going to use this one to kill this.
Right.
And then I can just switch these. So, you see? Yeah.
Okay.
Doesn't matter. As long as you end up with 2 zeros and a 1 here, I can just put the 1 in the right place. And it doesn't even matter if I don't do that, because it still means the same thing. So it's weird teaching this, because I'm trying to teach it in a very systematic way, at the same time making reference to you don't have to necessarily, there's a lot of different ways to do it, there's shortcuts.
I like to make different, all these multiple ways.
Alright, so, well then don't consider the other ways. Until you get more comfortable with how this works, then you can start to think about how can I make this shorter. But help me out. How would I use this 1 to kill this 4? Multiply this row. So take -4 times row 3. Add it to row 2.
And then you get row.
And put the answer where?
Row 2.
Row 2. I like it. Because I like this one. I don't want to lose this one. So I'm going to put the answer here. Yes?
The answer should be 1. -3 plus 4. Not, I think this is wrong.
What's...
Because the 4 should be 1, no 0. The 4th one. Yes, that's one.
What? I'm sorry. Where? What?
Because they all see 1, 1, and 1. But you put a -4 multiply R3 plus R2. Became 0, no 1.
I haven't put the answer yet. I haven't done that yet. I'm saying that's what we're going to do now, right?
Okay.
Is that cool? This, what I just wrote, we haven't done it yet.
I think that one is wrong.
Which one?
Because you put a -4 plus R3 became -4. But +4 became 0. But my answer should be 1, no 0.
I don't get it.
You know what?
Oh. Okay. Yes. Once we do this, there will be a 0 here, right?
1.
No. Once we do what we're about to do, there will be a 0 here, right? Yes, there will. I mean, do we want there to be a 0 there? Officially, no. But why did I write the equations in this order? Did it matter? Could I move this equation on top of that one? Couldn't I move these equations? Of course I can. So I can move rows around. That's why it doesn't matter. So once I do this, I'm going to just flip these.
The whole row?
Yes, because the whole row is one equation. So why am I allowed to just flip rows? Because I could have written this equation first and that equation, right? So I can certainly just flip rows all day long, because that's just the same thing as writing the equations in a different order. Who cares if I wrote that equation before that equation? Does that change anything? No. So can't I take this row and that row and flip them? Of course I can. I didn't change the equations.
Because we'll have the answers that.
So that by itself should not be a problem. If I would have written this, have I written any different? Have I written a different problem?
Yeah.
Have I written a different problem? Would the matrix look the same as it did here? No. What would be the difference?
The rows and see.
Yeah. So I can switch two rows anytime I want to, because it's just rewriting equations in different order. Who cares? Yes.
Are we gonna have to do the problems like this? Because I feel like the other way is easier.
Of course the other way is easier right now. Right? The other way is easier because we're more used to it. There are more things you can do with matrices than this. So what's one purpose why we put this now in this class? Because it's a use of a matrix, which you're going to have to use in later math, that is immediately related to something we just did. You see? So two things. It almost doesn't matter if the reality was the matrix step took longer than the other way, because you're getting used to matrices right now. But the reality is, this is quicker. I don't care what you think right now, because you're not used to matrices. So of course, anything to do with this is going to take longer, right? So if you're in a car, a monster fast car, you've never driven this kind of car before, you're probably not going to go very fast, because you've never driven the damn thing before. But once you get used to it, you're probably going to go fast. So it's exactly the same thing that's happening. We're in a car we're not used to. I'm probably not going to, like me, when I went to the UK recently, I was not going very fast when they upgraded me to the Peugeot. I was like, I've never been in a Peugeot before. This is really interesting. So I'm like, plus I don't want to, kill anybody or hurt my car, right? But I got used to it and started going a little faster and remembered to be on the right side of the road. Anyway, so when you're doing something new, it's going to seem harder than some other way before. Of course it is, because we're not used to this yet. But there's a lot of shortcuts to what I'm doing right now. I'm showing more. I'm trying to introduce one right now. Don't rewrite the damn thing. Do a second thing. We just did one thing. Now do a second thing at the same time before you rewrite the damn thing. But you also got to get used to it a little bit. Yeah.
So when you change the rows, isn't that messing up our R1 plus R3? Is that part of the answer that we're doing? Or that's
We're not switching any rows right now. Not yet. We can if we want to. We can turn them around so the 1 is kind of like in the right place. That's all we meant. Right now I'm not going to do that.
Right, but the R1 plus the R3 arrow R1, that's not part of the answer that you're looking for.
No, that's its own separate little equation. It's better than what I had here before because there's one less unknown in it.
Okay.
I like it. So now, what's negative 4 times row 3? Negative 4 times 0 is 0. Negative 4 times 1. Negative 4 times 6. Negative 4 times 8. And now I can add these together. 0 plus 0 is 0. Negative 4 plus 4. 0. Negative 24 minus 5. Negative 12 plus, negative 32, if I could just read my writing, plus 3. Yep. And then I got 0, 1, 6, 8. All right, let me stop there for a second. What's up? So I did, here's negative 4 times row 3 right there, right? And then I added that to row 2, and I put the answer in row 2. Row 3, I left the same way it was. I just undid this. All right, and what do we see that's remarkably nice up there? So you guys see this? Yes, negative 29z equals negative 29. How would you solve that? You would just divide both sides. So I can divide a row by a number. Obviously, what did I do to go from here to here? I multiply that row by negative 4. I can divide a row the same way. So what would I do to row 2? Yeah, divide by negative 29.
And then you can flip it.
And I could flip these, yes.
Yeah.
Let's see if we can do both at the same time. All right, let me leave row 1 alone. Just to go back to Keanu's point, because I could see it in your faces. Please understand that there are so many uses to matrices. So even if you're like, oh, what the shit is this? I understood when we were doing X's and Y's and Z's. Why is he doing this? It's so much easier the other way. Like you said, it's easier because we're used to it. There's a whole other reason I want to get used to matrices. Because matrices are used for a lot of things. Right? So this is our first little intro to matrices. Using them for a problem we know how to do a different way. So I can get the problem that way and know what the answer is, and then I can get it this way and go, okay, the matrix worked the same way, okay. Alright, so I left row 1 alone. Divide this by negative 29, I get 0, 0, 1, 1. And the last, I was going to switch the 2. I know I was screwed. Okay. Forgot I was going to switch them at the same time. Oh well. So do you see that middle row? It's this guy here, right? It's okay. It's not in the middle. I could put him on the end if I wanted to. I can switch those. But what does it tell me? That tells me that Z is 1. Okay. Now, which column doesn't look the way it's supposed to? That last one. And do you see how this guy is like a laser, right? You can laser and kill this guy. These won't screw with these. So I can make that 1 kill that 7 if I multiply this by negative 7. I can make that 1 kill that 6 if I multiply this by negative 6. So 11.
How do you show that though? Do you just know that way to do that?
Well, you show it like this. You say, what do we just say? Negative 7 times row 2. I'm going to add that to what? Row 1, because that's where that 7 is that I don't want. I'm going to put the answer in row 1. Now again, I'm going to try to show you the shortcut that I just showed you earlier. Yes?
Never mind.
Okay. I can do that. So, when I multiply 0 by anything, it's still 0. That's negative 7 now. That's negative 7. Multiply that row by negative 7. Why? To kill the 7 that's up there above it. I like it. Some of you guys, I can't tell if you get it or not, but you're fading. I understand. Alright. So now this first row becomes 0 plus 1 is 1. 0 plus 0 is 0. Negative 7 plus 7? 0. Negative 7 plus 10? 3. So now I know X is 3. Cool. Now, as promised, do I need this anymore?
No.
No. Alright, screw it. So now I'm going to also multiply row 2 by what to kill the 6? Yeah, so negative 6 times row 2 plus row 3. Put the answer into row 3. So I can kill that 6 that's there that I don't want. I love the reaction of some of you guys. Alright. Math finds a way to get worse. Now stop. So it's 0, 0, negative 6, negative 6. So that if I do that, I don't have to rewrite this matrix over and over again. I agree with you. When I first learned it, I'm like, oh shit, I want to write out. So now it becomes 0, 1, right? 0 plus 1. Negative 6 plus 6, 0. Negative 6 plus 8, 2. So now I know X is 3, Y is 2, and Z is 1. Right? And that was the one that was on this side, 3, 2, 1. Same answer. I love it. I know I'm going to get people, well, this was a quicker there, Mr. Waller. Screw you, Mr. Waller. No, stop. Please, I already said all this stuff, the reasons, right? And this is not even the quickest this could be. You could have done that kind of thing from the beginning. There's a lot of ways to make this process quicker. And even if you don't believe me on that, you got to know how matrices work. Period. All right. Yes.
The goal though for there's no one.
I know. So, I could switch these. And now 3, 2, 1 is my. So if you put it in this form, you can read the point off. If it's not in that form, if it's out of order, then you can't. That's not the point there, is it? It's out of order. If you put it in order, then it's in order. But that's who kind of cares. But officially, this is where you want to end up. If you don't quite end up there, as long as you can tell what X, Y, and Z are, you're there. So here's the next level of goodness. I'm going to use something in the calculator, so if you want to borrow one. And this, I think, will be the last thing we do. We're all especially fading today.
So if you had a test, you would give us these properties. Is that good in a matrix? Is that how it works?
So there's going to be, obviously in the next test, there's going to be, do this by hand, like this way, right? And then,
And then you'll give us that.
Yeah.
That.
very often what I do, I give you the same, so you already know what the answer is supposed to be.
Got it.
So you kind of can see where the matrix if you're making a mistake. Yeah. As long as you did this one right. Alright. So as I said earlier,
Yeah.
one big bonus to this that we don't immediately appreciate is that this whole process is very easy to program. You just tell a computer, if you don't see a 1, make it a 1. And the computer, like right here, why didn't I divide by 4 and make that a 1? Because fractions. Does the computer worry about fractions? No. It's programmed to not be wrong. That's nice for it, right? That's how you can tell it's a freaking computer. It never makes a mistake. Well, so I can just tell it, if you don't see a 1 here, make it a 1. Then kill these. If you don't see a 1 there, make it a 1. Then kill these. I can just tell it to do that. And then I don't care how big the matrix is. I just say, keep going until you run out of columns, computer. Right? So that's why it's easy to program. So let's see how to do this in the calculator. It's been programmed into the calculator.
Can you help me out here?
What's up? What's up? Who's?
Stuck in plotting.
Oh, if you ever get stuck somewhere, hit settings. Mode. Right. There you always get you back to the home screen. So we're going to do the same problem in the calculator and see if we get the same answer. So incredibly enough, let me first say this. The official name of this form is reduced row echelon form. Do the words matter or shit? No. There are reasons that we use those words. Reduced row echelon form, also known as RREF, is equal to reduced row echelon form. There's a reason I'm telling you that, because in the calculator there will be an option that's RREF. That's what we're looking for. There's an option that's REF that reduces it not all the way, just brings it to row echelon form, doesn't give me all the zeros I want, so screw that form. Alright? Alright, that's all I got to know about that. So what button, where do you think I'm going to go to do this? No? Look right below the one. See this right above this button here? It says matrix. So you can enter the matrix here. All right, now the way this is hardwired leaves a little bit to be desired, but oh well. This is how you can refer to a matrix you've already made. Now, some of you guys might have some numbers showing up over here. I don't know. Does anybody have a number showing up over here? 3 by 4, 2 by 3. So I would call this a 3 by 4 matrix. You see that 3 rows by 4, sort of like a 2 by 4 piece of wood. So I don't have, even if you have numbers over here, just go over, I need to edit my matrix. And let's all use matrix A. So even if yours says something, we're going to override it anyway. Is everybody with me?
The row goes that way, right? That's what a row is.
Yeah, this is a row, and this is a column. So there's 3 rows by 4 columns. So I call that a 3x4 matrix. All right. Is everybody in this screen?
Yeah.
All right. If you need a calculator, still 2 in there. So select edit, and mine isn't already created. So even if yours has numbers in there, just make it 3.
What's your question? I'm sorry.
All right, let me come back. So you go second, x negative 1. So you get the matrix. Go over to edit. I can't remember. I'm pretty sure I put this on the Bible, on the guide. I used to call it my calculator Bible. This is something I gotta put in here. Maybe it's something I gotta put in here. Yeah, I gotta put in there. All right. So go to edit, enter. Now, for me, it started off as a 1 by 1, which is kind of silly because it's just one number. So I'm going to make it 3. Oh, get out of there. 3. 3 by 4. All right. Because I don't want 3 rows, 4 columns. So has everybody got that going?
Yeah.
I like it. So now just input the coefficients. And just as easy as it is to forget a negative when you're writing it, it's just as easy when you're putting it in. Negative is here. This is the negative button. Right here. You see what I'm circling?
Mm-hmm.
That's minus. No. Negative. Yes. So let's see what we got. We got 1. I won't say it out loud. Just put them all in there. Hit enter when you get them. See. Everybody doing okay? So I'm just looking right there for my matrix.
It's negative 2.
No, it's 2, isn't it? Oh, here.
1, yeah.
Thank you. I wish I could say I did it on purpose, but I didn't. So all it takes is one stupid number to be off, and the whole thing goes to shit. So when you're doing your homework, you will want to triple check the numbers in the book and the numbers you wrote down on your paper. Like maybe should have happened a little more often with the test,
Yeah.
for example.
Is this supposed to equal negative now?
Hold on. I haven't even shown you how to do anything yet.
Oh, on top of the
It shows negative 9,
yeah, it shows negative 9.
It's a negative 9. It's supposed to be 9, right?
Yeah, yeah.
Okay. Yeah, Jack. All right. Good. It's always good to have a room full of eyes on what you're doing. All right. So now, here's the evil thing about matrices. Anytime you create a matrix, you got to get the hell out of it. Because if you try to do something right now, it's going to try to put the answer right there. And if the answer is a matrix, it's going to give you an error. Shit, what the hell? So anytime you put a matrix in, hit second mode to quit. Get the hell out of it. Alright, now you can do shit to it. You're not in it, so now I can do stuff to it. So what do I want to do to it? Rough it. Right? R-R-F it. Some of you guys might just, shorten that to F it. So if I go back to matrix, I can do math. And if you scroll down, let me stop there. Is everybody with me? Go back to the matrix, then hit the arrow over for math. You should get this list of a whole bunch of shit that doesn't make any sense. I know the word fill, but what the hell does it mean? Well, we don't worry about it. Scroll down until you see something related to Earth. So I see REF, that's not good enough. I need RREF.
What do you do once you're done filling it in?
Oh, okay. Go back to matrix. Go to math. Because now I want to do math to my matrix. And then scroll down until you get to that RREF. That stands for this process we're doing up here. This is also called Gauss-Jordan elimination. Again, more words that just references this process. We just wanted to give props to the people that made this up. So B for me, I don't know if it's true for everybody. So hit RREF now. Don't. So hit enter. All right, now. Do you see how it's like do that to what? Go back in the matrix. And now names is where you can pick a matrix. So I already have matrix A made. I'm going to pick matrix A. So it should look like that. All right. Let me do it again. So go back into matrix to math. So RREF. Then go back into matrix to names, and you can pick matrix A. So I want to row reduce matrix A. And if I just say row reduce, that actually makes sense. That feels like what this is, right? Row reduce. I'm reducing the rows, making zeros. Now if I hit enter, with your help, it comes out nice. Right? Yes, sir.
I can't figure out.
Oh, so you want this way for now? Or are you?
22 to 29.
Right, that's all.
Oh, you've already got it. Oh, you're in the matrix. That's what's happening. So anytime you make a matrix, it's a second, you're going to get the hell out of it. So quit. Now go back to the matrix. That's the one thing I don't like about how they hardwire this out of this one. You always have to get out of it before you go do something.
Right.
Yeah.
Easier one.
Yeah.
I like this better.
All right, let me go back. What's up? Yours. So if I hit second matrix math, there should be an REF and then an RREF.
Got that.
Okay. Hit
Oh,
enter. And then you go back to matrix and tell it which matrix you want to use. Because you can have many, many matrices in there. How are we doing?
Thank you.
Did something?
Did something. Okay. Did it good? Oh, free.
Right.
Oh, I see.
Do something.
You need to tell us RREF. Do that to now go back into matrix and tell it A. Do that to matrix A. No. So now just go back to the matrix. And hit enter for A. So now it's going to row reduce matrix A. Here you just had show me matrix A. Yeah, so there's the answers. So real quick, if I would have left that mistake in there, doesn't really matter which one, but let me just make this a -9. More than likely, the answer is going to be gross. Yeah, look at that. Yeah, maybe yeah. Now if I do math, let's see if it does something to fraction. Hey, look at that, that's neat. So, in the real world, the answers might be gross like that. I can tell it to do it. I showed you that button the other day, the fraction button. It can do that for a whole matrix too. It can make all these become fractions if it can. That's kind of nifty. You shouldn't have to do that too often, I don't think. All right, now some of you guys are like, well, that was easy. Why do we got to do it? Because this is you, and that's it. Again, you don't want that passing and you staying. That's no good. But this is nice. You can check your work. You can check your work this way. Right? It's a good way to check your work. Check your work. Okay, and I think they spell out, in the book at least, they tell you, yes, they tell you the steps for the calculator, since I didn't put the matrix stuff on my, I don't know why I didn't, but I just didn't. All right. That's enough for today. So that's it for chapter 9. All right. Have a good weekend.